So far we have discussed about the introductory concepts of microprocessor architecture and its various functionalities. In this course we are going to looking into the architecture, pin diagram, then addressing modes and instruction sets of microprocessors 8085 and 8086, followed by various interfacing devices such as 8259, 8279 and DMA controller. Finally, we are going to discuss about 8051 microcontroller. Now let us start with 8085 microprocessor. In later days, this 8085 microprocessor is called as 8085 MPU. The term MPU refers to microprocessing unit, which refers to the group of devices that performs the functions of a single microprocessor. It is termed used in the earlier days. Now let us discuss about properties of 8085 microprocessor. The first property is it is a 8-bit processor. In the sense, it is defined using the number of data lines present in the architecture, microprocessor architecture. Since the number of data lines present in 8085 microprocessor is 8, then it is able to process up to data bits of 8 bits. Suppose if the number of data lines is 16, for example 8086 microprocessor is a 16-bit processor because the number of data lines present in that 8086 microprocessor is 16, hence it is called as 8-bit processor. In 8085 the number of data lines is 8, hence it is called as 8-bit processor. Next, this 8085 microprocessor is capable of processing 64 kilobytes of memory. It can store data up to 64 kilobytes of memory. So this property is based on the number of address lines present in the microprocessor. Since the number of address lines present in this 8085 microprocessor is 16, then the available or the maximum memory capacity is calculated using 2 to the power of value, 2 to the power of 16, that is 2 to the power of 16 is equal to 64 kilobytes of memory. Next, the third property is the pins. The total number of pins in this 8085 microprocessor is 40. It is made up of 40 pins. Next is, it requires plus 5 volt power supply for performing its operations. And the last important property is, it requires 3 megahertz clock frequency, or it is the execution speed of the 8085 microprocessor. So these are all the 5 important properties of 8085 microprocessor. Let me recall once. First is, it is the 8-bit processor and it is based on the property that the number of data lines present in this 8085 processor is 8. It is capable of processing data of 8 bits. Next is the memory capacity. The available memory capacity of 8085 microprocessor 64 kilobytes, and this property is based on the number of address lines. Since the number of address lines is 16, we can calculate the memory capacity as 2 to the power of 16, which equals 64 kilobytes of memory. Then the total number of pins present in 8085 microprocessor is 40. Then it requires plus 5 volt power supply for performing its operations. And it also requires 3 megahertz clock frequency, which is referred to as execution speed of this processor. Next, we will look into the pin diagram. Next, we will look into the pin diagram of 8085 microprocessor. We know that 8085 microprocessor is made up of 40 pins. So on the left side, it is numbered from 1 to 20 in top to bottom fashion. On the other side, it is numbered from 21 to 40. So on the other side, it is numbered from 21 to 40 in bottom to top fashion. So this is the pin configuration of 8085 microprocessor. The predecessor of 8085 processor is 8080A, and the successor of this 8085 microprocessor is the second version of 8085 version 2, and the operating speed of this second version of 8085 processor is 5 MHz. So this is the pin configuration of 8085 processor. And before looking into the pin description, we have to note down two important points or two important terms during this pin diagram. First point is active high pin, and the next term is active low pin. The term active high refers to whenever a signal or a bit is set to 1 over the corresponding pin, it is said to be active high, or it requires the positive power supply, then it is termed as active high pin. And whenever the corresponding signal or bit is set to 0, then the pin is termed as active low pin. It means that this pin starts functioning or starts executing the function whenever it receives the value 1, whenever the bit value is set to 1, and this pin, active low pin, starts performing its function whenever the corresponding bit or signal is set to 0. So these we have to remember, this one, active high and active low. Active high means this pin starts performing its function whenever the bit value is set to 1, and the active low pins start performing its function whenever the bit or signal value is set to 0. So we have to remember this concept. Now coming back to this 8085 pin diagram, first two pins are X1 and X2 pins. So the direction of the arrow marks represent that it is the input pin. So these two pins, X1 and X2, are used to receive external clock frequency. These two pins are used to receive external clock frequency from crystal oscillator or any other electronic oscillators that are made up of LC or RC network. And this 8085 microprocessor, whenever it wants to operate at the speed of 3 MHz, then the external clock frequency that should be given as input should be 6 MHz. If this 8085 processor wants to work at the speed of 2 MHz, then the input frequency, that is external clock frequency given as input, should be 4. It means that the concept is whatever the external clock frequency is given as input via this X1 and X2 pin, it will be divided by 2 internally by the processor. So this is about X1 and X2 pins. Then they are the input pins. It is indicated by this direction of the arrow mark. Next pin is reset out pin. So the third pin is reset out. It means that whenever this pin is active high, then it resets all the connected peripheral devices of this microprocessor. So this is the function of reset out pin. And X1 and X2 followed by reset out, that is the third pin. Reset out means it resets all the externally connected peripheral devices of this microprocessor. So this is the function of reset out. Then the next pin is SID pin and SOD pin. So whenever we look into each and every pin, we have to remember whether it is active high or active low, and whether it is an input pin or output pin. Here the fourth pin SID is input pin and SOD is output pin. Likewise, X1 and X2 are input pins and the reset out is output pin. They are indicated by this direction of the arrow marks. So SID refers to serial input data. SID refers to serial input data and SOD refers to serial output data. Serial input data means the function of this pin is whatever the parallel data is received by this 8085 microprocessor, it will be converted into serial. Next pin we are going to discuss is, so the function of this SID pin is, it is used to receive serial data from the externally connected peripheral devices and it will be sent to the 8085 microprocessor. And the function of this SOD pin is, it will send the or it will transmit the serial data to the externally connected peripheral devices. So these two properties, we have to look into these two properties or these two. So we have to look into these two pins, SID and SOD. So SID refers to serial input data and SOD refers to serial output data. So SID, the function of this SID pin is, it receives serial data from the externally connected peripheral devices. After receiving the serial data from the externally connected peripheral devices, it will be converted into parallel data because 8085 microprocessor is capable of processing only parallel data. Now we will discuss about the difference between serial data and parallel data. Serial data means data will be transmitted over a single line, one by one. In serial transmission, data will be transmitted over a single line and one by one fashion. Whereas in parallel transmission, data will be transferred over multiple lines parallelly. So that is the difference between serial transmission and parallel transmission of data. So the processor 8085 is capable of processing only parallel data. So the conversion is done here. And the converted parallel data will be again so the converted parallel data should be again transmitted to the peripheral devices, but the peripheral devices are capable of processing only serial data. Hence, the function of SOD pin is used to convert parallel data to serial data. So this is the function of this pin, SID and SOD. So SID is the input pin and SOD is the output pin. SID means serial input data. This pin is used to receive serial data which will be converted internally into parallel data by the processor. And the function of this SOD pin is used to convert the parallel data to serial data which will be sent to the external process devices. So these are all the functions of the first 5 pins. Next, from pin 6, let's start with interrupt pins. They are called as interrupt pins. The first interrupt pin is called as trap, then RST 7.5, next RST 6.5, then RST 5.5, then the 10th pin is INTR interrupt. These are the 5 types of interrupt pins. 5 types of interrupt pins. So, whenever externally connected I/O or peripheral devices want to send any interrupt request, they will send the request via any of these 5 interrupt pins. Once the processor receives any interrupt request on these pins, then it sends an acknowledgement to the corresponding peripheral device via 11th pin, that is interrupt acknowledgement. and it is represented using INTA bar. If you append this bar with the corresponding pin, then the pin is referred as active low pin. That is, it will start performing its function whenever the value of the bit on the corresponding pin is set to 0. Then it is called as active low pin. So the term interrupt, we have already discussed about this term interrupt. The term interrupt refers to, we have already discussed about the term interrupt. Interrupt means whenever the processor starts executing its normal operation and this interrupt request is sent to this processor by any external peripheral device, the processor will stop its normal execution and starts executing some other set of instruction called as interrupt service routines. So that is the concept of interrupt. Then after performing that interrupt service routine, the processor will again start executing its normal function. It is similar to reading a book, and when you receive a phone call, you will mark that page with any bookmarks, and after attending the phone call, you will again start reading the corresponding page. The concept of interrupt can be compared with reading a book. When you read a book and when you have a phone call, you will mark that page with any bookmark, and after attending the call, then again you will start reading the same page by referring to the bookmark. Likewise, the processor also the process will start executing some set of instructions, that is the normal execution, and whenever the processor receives any interrupt request from the external devices, it will stop its normal execution and start executing the service routine. And after completing the service routine, and again the processor will start executing its normal function. So this is the concept of interrupt. And this is INTA pin is interrupt acknowledge. It is an output pin, and these interrupt pins are all of input types. Next pin after INTA is AD7, AD6, AD5, AD4, AD3, AD2, AD1 and AD0. So these are all the 8 pins. They are called as multiplexed address and data bus. Address and data bus. So these 8 pins are called as multiplexed address or data bus. The term multiplexed refers to, it is used as multi-purpose. It means that the same set of 8 pins can be either used as address bus or data bus. So this is the concept of multiplexed address bus. And during the first clock cycle of any machine cycle, these pins will act as address bus, and in the remaining clock cycles, these pins will act as data bus. And this is also based upon pin number 30, and the pin is called as ALE pin, that is address latch enable pin. That is, whenever the value of this pin ALE is set to 1, then these multiplexed address and data bus will act as address bus. And if the value of this ALE pin is set to 0, then these multiplexed buses will act as data bus. So this will happen during the first clock cycle of any machine cycle, and this will happen during the remaining clock cycles. So this is about multiplexed address and data bus. And here the address, we know that the address of 8085 microprocessor is made up of 16 bits. But here we have represented only 8 bits or 8 pins. The reason is, when you consider the 16-bit address such as 4250H, here the H refers to hexadecimal representation, and whenever the 16-bit address is given in hexadecimal format, it will be manipulated by the processor in the binary format only. So the binary format for representing the 16-bit is for 0, 0, 0, 0, 0, and for 5, 0, 1, 0, 1, and for 2, 0, 0, 1, 0, and for 4, 0, 1, 0, 0. So this is the 16-bit representation of this 4250H memory address. So this is 16 bits. Here we have represented only 8 bits. It means that, and the value here we have mentioned is A7, that is AD7 to AD0. It means that we have to split this 16-bit address into two parts as lower order address and higher order address. So in this multiplexed address and data bus, this lower order address alone will be carried over here, and the remaining higher order address values are carried by the pin 21, A8, A9, A10, A11, A12, A13, A14, A15. So these 8 pins, are used to carry the higher order address. Here it is used to carry the lower order address values or address bits. So this is about concept of carrying the 16-bit address using these pins. And the pin 30 is called as VSS pin. So this is the ground reference pin, ground supply or ground reference. And the pin number 40 is called as VCC, and this is the pin used to receive the plus 5 volt power supply. If receive this power supply only, the processor can execute its corresponding operations. We have finished up to 20th pin, and also we have discussed about pin 21 to 30. They are higher order address bits. And the pin 29 is called as S0, and the pin 31 is called as S1. So these S0 and S1 pin are called as status pins. S0 and S1 pins, that is pin number 29 and 33, they are called as status pins. They are used to identify the current status of the processor, that is whatever operation, whether the processor is performing read operation or write operation in the IO or memory, it will be indicated by these two pins S0 and S1. They are called as status pins. And the pin 30 is ALE, we have discussed already, that is address latch enable. Whenever the value of ALE is set to 1, then the multiplexed bus will act as address bus in the first clock cycle. Whenever the value of ALE is set to 0, then the multiplexed bus will act as data bus in the remaining clock cycle. And after that, it is followed by read and write pins. So we know that these two, write and read, are indicated with bar over the pin names. Hence these two are active low pins. It means that these two pins will start executing its function whenever the signal or bit received over this pin is 0. So write means it performs write operation either into the IO device or memory. Then read means it will perform read operation. The processor will perform read operation either from the IO device or memory. Next is S0, we have discussed already. Next, the 34th pin is IO bar M bar. It means that this pin is used to indicate whether the processor is performing read operation or write operation over IO device or memory. Performs, and the M refers to memory. So this pin 34 is used to indicate whether the processor is executing its read or write operation over IO or M. Whenever the value of this pin is set to 1, then the read or write operation is performing over IO device. And whenever the value of this pin is set to 0, then the read or write operation is carried out on the memory. So this is the function of this pin. Next, 35 pin is called as ready pin. So we have discussed already during the introductory part, that is the function of this ready pin is it makes the processor to enter into low wait state. It means that it is used to synchronize the processor with the slower peripherals. And the 36th pin is reset in. The reset in is the active low pin. It is used to, whenever the pin is active low, then it used to reset the processor, and the program counter value is set to 0. Next, the 36th pin is reset in. It is an active low pin. Whenever the pin goes low, then the processor gets reset. That is, all the values will be set to its default value, and the program counter value is set to 0. The content of the program counter is it stores the address of the next instruction. It will be set to 0. So that is the function of reset in pin. Next, clock out. Clock out means the clock signal or clock frequency is given to externally connected peripheral or IO devices. And the 38th pin is hold, and the 39th pin is hold acknowledge. Whenever this processor 8085 receives the hold signal or hold request from externally connected peripheral devices, this processor will relinquish the control over the address and data bus to the requesting IO or peripheral devices. The 38th pin is hold pin, and the 39th pin is HLDA, that is hold acknowledge. Whenever the processor receives a hold request from externally connected peripheral devices, the processor will relinquish the control over address and data bus, and the control will be surrendered to the requesting IO device or the peripheral device. And HLDA refers to hold acknowledge. The 39th pin is HLDA, that is hold acknowledge. When the processor receives hold request from the externally connected peripheral device, it sends an acknowledgement via this HLDA pin, that is hold acknowledgement to the corresponding peripheral device. Then 40th is VCC, that is the plus 5 volt power supply pin. So we have discussed all the functions of this 40 pin configuration. So we have discussed the functions of all the 40 pins. Let me summarize the functions once again. First two pins are X1 and X2. They are used to receive the external clock frequency. Then third pin is reset out. It is used to reset the externally connected peripheral devices. And the fourth pin is serial SID, that is serial input data pin. It is used to receive the serial data from the externally connected peripheral devices, which will be converted into parallel data by the processor, and the converted parallel data will be again sent as serial data, and it will be sent to the corresponding IO device through this pin SOD, that is serial output data. The next pins trap RST 7.5. The next pins trap RST 7.5, RST 6.5, RST 5.5 and INTR. These are the 5 types of interrupt pins that are used to receive the interrupt signal. And the 11th pin is INTA, that is an interrupt acknowledge. Whenever the processor receives an interrupt signal via these pins, the processor sends an acknowledgement via INTA. And the next 8 pins from AD 7 to AD0, they are called as multiplex address and data bus. In the lower part of the clock cycles, these multiplexed address will act as address bus. The next pins from 12 to 19 are multiplexed address and data bus. These multiplexed bus will act as address bus during the first clock cycle, and whenever the value of this 30th pin ALE, address latch enable, is set to 1, and this 8 pins will act as data bus in the remaining clock cycle, and also when the value of this 30th pin ALE is set to 0. And VSS is the ground supply pin, and VCC is the 40th pin. VCC is the plus 5 volt power supply pin. And pin number 21 to 28, they are used to carry the higher order address bus. And here from AD7 to AD0, we will be carrying, the processor will be here from A8 to A15, these pins are used to carry the higher order address bus. These pins A8 to A15, they are used to carry the higher order address bits. Then S0 and S1, this 29 and 33 pin are the status pins, and 31 and 32 are read-write pins, and 34th pin is IO or MOM. It refers whether the processor is performing read or write operation over the IO device or memory device. And 35th pin is ready pin. It is used to synchronize the slower peripherals with the corresponding microprocessor. Then 35th pin is the ready pin. It makes the processor, the 35th pin is ready pin. It makes the processor to enter into low wait state. And the 36th pin is reset in, and whenever the pin goes low, the processor gets reset. And 37th pin is clock out, and it generates the clock frequency required by the externally connected peripheral devices. And 38th pin is hold. Whenever the processor receives hold request, it will surrender the control of the address and data bus to the requesting device. And whenever it receives the hold request, it sends an acknowledgement to the corresponding device via HLDA. So this is all about pin diagram of 8085 microprocessor. Hope you will remember all these functions. Next we will look into 8085 architecture. So this is the block diagram of 8085 microprocessor. Now let us discuss about the architecture of 8085 microprocessor. That is, what are all the components present in 8085 architecture. The first one we have to discuss is about ALU, that is arithmetic logic unit. The function of this unit is used to perform various arithmetic and logic operations. The example of arithmetic operations are addition, subtraction, increment and decrement. And the examples of logical operations are AND, OR, NOT, complement. So these are all some of the arithmetic and logical operations that will be executed by this unit, arithmetic and logic unit, shortly called as ALU. The next component is accumulator. So it is used to store 8-bit data. That is, it is used to hold one of the operands required for this arithmetic or logical operations. It is the main register of 8085 microprocessor. Next is the temporary register. It is also used to hold 8-bit data, and it's used to store the intermediary results during arithmetic and logical operations, and it's not available to the user. It will be used by the processor internally. Next is the status flag. So it is the register that is used to store the condition of the status flags. So there are 5 types of status flags. First one is sign flag. Second one is zero flag. Third one is auxiliary carry flag. Fourth one is parity flag. And the fifth one is carry flag. So the term sign flag refers to So the first one is sign flag. The value of this sign flag is set to 1 when the result received. So the value of the sign flag is set to 1 whenever the value of D7th bit is 1. It means that the result we obtained after any data manipulation. The value of this sign flag is set to 1 whenever the D7th bit value is equal to 1. It means that the result we obtained after arithmetic or logical operation is negative. And the sign flag is set to 0 if the D7th bit value is 0 and it indicates that the result we obtained after any arithmetic or logical operation is positive. It can be explained clearly that, for example, if the processor is performing an addition operation between two hexadecimal values 20H and 80H, it will be processed internally as the value binary. It will be processed internally as binary values 0010 000 1000 and the processor is performing addition operation, for example 0 0 0 0 0 1 0 1. So this is the D0 bit, D1, D2, D3, D4, D5, D6 and D7. Now the value of D7th bit is 1. If this D7 bit is 1, then the sign flag will be set and indicates that it is a negative value. Next is the 0 flag. 0 flag means, next is the 0 flag. The flag value is set to 1 whenever the result of the operation is 0. And the 0 flag is set to 0 if the result is a non-zero value. It will be explained as, if you complement any value 20H and then 20H, that is if you are performing any XOR operation between the same values, the result we obtained is XOR operation. Then the result we obtained is all zeros. If we get result like this, all zeros, then the 0 flag will be set to 1. Next is the auxiliary carry flag. This flag will be set to 1 whenever there is a carry from D3rd bit to D4th bit. If there is no carry, then this flag will be set to 0. For example, if you perform add operation between FF and FF, 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. If you add these two values, so during this addition operation, there is a carry from, this is D0, D1, D2, D3. D4, D5, D6, D7. So there is a carry from D3rd to D4th bit. Hence the auxiliary carry flag will be set to 1. If there is no carry, it will be set to 0. Next is the parity flag. Parity flag will be set to 1 if there is even number of ones in the result. Let us consider the same example. And let us consider the same example. Here the number of ones is 1, 2, 3, 4, 5, 6, 7. So the total number of ones here is 7. So the parity flag will be set to 0. If there is even number of ones, then the parity flag is set to 1. If there is odd number of ones, then the parity flag will be set to 0. So this is about parity flag. And the next is the carry flag. When we consider this same example, when there is an extra bit after the D7th bit, then it is called as carry bit and the carry flag will set to 1. If there is no extra bit after this D7th bit, then it is no carry. It will be set to 0. So this is about flags. So first one is a sign flag, next is a zero flag, auxiliary carry, parity and carry flag. The contents or the status will be stored as a flag register in the 8-bit format as sign flag, zero flag, don't care bit, auxiliary carry, don't care bit, parity flag, then don't care bit, then carry flag. So the content will be updated here. So this is the flag register. So this will be stored in this part, in this register status flags. So this is about processing unit. Now let us start with the storage and interface unit. The first one are the 6 types of general purpose register. They are named as. Next we will start with the storage and interface unit. It consists of 6 types of general purpose registers as B register, C register, D register, E register, H register and L register. Each of these registers are capable of holding 8-bit values. Whenever the processor wants to perform any operation over 16-bit data, then these single 8-bit registers can be grouped into register pairs. And the valid register pairs are BC, DE and HL. So these pairs only valid. So whenever the processor wants to execute any 16-bit operations, these valid register pairs can be used to hold the 16-bit data. And next is the stack pointer. So this stack pointer is used to store the address of the. So next is the stack pointer. This is used to store the address of the top element in the stack. Next is the program counter. As we know, the program counter stores the address of the next instruction that is to be executed by the processor. Next is the increment or decrement register. It used to increment or decrement the address present in the stack pointer or program counter. It is also 16-bit. Next is the address latch. So this address latch is used to separate the higher order. Next is the address latch. So this latch is used to separate the address bus from the multiplexed address and data. So next is the address latch and this is used to separate. Next is the address latch and this is used to transmit the higher order address lines. And this is the address data latch and this is used to transmit the multiplexed address and data lines. So this is all about storage and interface unit. Next comes the instruction unit, which starts with instruction register. So this instruction register is used to store the information about the instruction that is being executed, such that it stores the opcode. Next is the instruction register, and this register holds the instruction that is currently being executed. And next is the instruction decoder, and the function of this decoder is to decode the number of machine cycle required by the instruction that is currently being processed. And after decoding, the value will be given to timing and control unit. So this timing and control unit is responsible for all the timing and control activities that will happen within this processor. Whenever the number of machine cycles is received for a particular instruction, it will be again further divided. The function of this timing and control unit is used to receive the function of this timing and control unit is used to receive the number of machine cycles for the current instruction, and it will be executed by this unit. For example, if the processor wants to perform read, write, or if the processor wants to execute any read or write operation, then based on the machine cycle received, this unit will instruct the processor to perform its corresponding function. So this is all about instruction unit. Next is the serial I/O controller unit. So this control unit is responsible for converting serial data to parallel data and parallel data to serial data. The processor is capable of processing only parallel data. So whenever serial data is received from this pin SID, it will be converted to parallel data internally by a serial I/O controller. And again the parallel data will be sent as serial data to the corresponding peripheral devices. And next is the interrupt controller. This unit is responsible for managing all the interrupt requests and interrupt acknowledgement. We have already discussed there are 5 types of interrupt pins: trap, RST 7.5, 6.5, 5.5 and INTR. And this is the and the priority wise, trap has the highest priority and INTR has the lowest priority, and INTA is the interrupt acknowledgement signal. So this is all about 8085 architecture. Let me summarize once again the functions of the blocks present in 8085 architecture. First one is the arithmetic and logic unit. It is used to perform arithmetic and logic operations such as addition, subtraction, increment, decrement, and or. Let me summarize once again the function. Let me summarize once again the functions of the 8085 architecture. First part is arithmetic logic unit. It is used to perform various arithmetic and logic operation. Then accumulator is the main register. It is used to hold one of the operand values required for this arithmetic and logic operation. And this is the temporary register. It is not available to the user, and it's used to store the intermediary results during data manipulation. And it is used to store the status of the flags. There are 5 types of flags. First one is sign flag, zero flag, auxiliary carry flag, parity flag and carry flag. So this is about processing unit. And next is the storage and interface unit. There are 6 types of general purpose register: B, C, D, E, H, L, and each of these registers are capable of holding 8-bit data. And if the processor wants to manipulate any 16-bit data, then these registers can be
Whenever the processor wants to manipulate a 16-bit data, these registers can be grouped as register pairs, and the valid pairs are B, C, D, E, H, L. And stack pointer is used to store the address of the top element present in the stack, and program counter is used to store the address of the next instruction being executed by the processor, and the increment or decrement count register is used to increment or decrement the values present in the stack pointer and program counter, and address latch is used to transmit the data over higher order address lines, and address or data latch is used to transmit the address or data values through multiplexed address lines and data lines. And next is the instruction unit. This instruction register holds the current instruction that is being executed, and this instruction decoder decodes the machine cycle required for this instruction, and it will be sent to the timing and control unit. And this timing and control unit, after receiving the decoded information, it will start executing or start synchronizing with the given input value, and and the processor will the timing and control unit, after receiving the information from the instruction decoder, it will start synchronizing with the corresponding operation of the processor. Next is the serial IO controller. This is used to and the next is the serial IO controller, and this is used to convert serial data to parallel data and parallel data to serial data. Next is the interrupt controller, and it manages all the interrupt requests and acknowledgement. So this is about 8085 architecture.